Is tracing muscles of the eyeball. Different actions of noticing stress.
A lot of amazing videos, and yeah, they are very educative. And the subscription is free. Just go online and hit the button.
About 50 videos are available for you. Educative and informative, inspiring and entertaining industrial production processes. Sir Majesty Easy World is an online school of science. No school fees, no stress. We teach the real thing. Just visit and subscribe. Thank you.
I'm a second year in
My name is Sushma Tripathi, I'm a first year medical student.
We're here today to ask you to please subscribe to Sarah.
Good afternoon, Stanley Wilson. Okay, nice to see that you're there. Welcome once again to Sir Majesty Easy World Science channel. Today, we will do our final revision about this forthcoming examination, which will be taking place tomorrow. Today, I've decided to bring formal JAMB questions just to make it easier for you today. So, the questions today is going to be easier than the ones you have been seeing before. The other ones I've been giving you are tough questions, which are meant to train you and make you stronger. But this time around, you are going to see something related to what you will see in the examination hall. But remember, in this live stream, your questions will help me a lot, because here I am keen on giving you the cheats and the shortcuts on how to deal with some calculations in this forthcoming JAMB examination. So I wish you the best of luck. As usual, this is stream 6. I will display the questions that I will be answering. It is about 30 questions or so. I didn't even take much time to look at the questions, but as far as I know, it's JAMB question. You can deal with them. So try your ability now. It's a kind of, let's say, an ad hoc or a quick assessment of your ability. So I'm going to play those questions. So try typing their answers as quickly as possible, because we are now assuming the exam is on. You see the question 1 and 2. I hope they are very clear. This question 3, 4 and 5. Okay, try your abilities, provide your answers. This question 6 and 7. Come on, I'm not seeing any answer. Are you not seeing those questions? Try your ability, please. I know I will answer them, but let me hear from you. That's the reason for the live chat. Okay, so let's start as usual. We'll take question 1. I think these are very, very cheap questions, of course. We go to our notes to solve them gradual. But before then, I will just give you, I think the answers are a bit cheap. Number 1 says, okay, number 4 is starch. That's correct. Okay, Stanley, well done work. That's what I expect from you. The electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. How many unpaired electrons are there in the element? Simple, there are 3 unpaired electrons. The answer is C. Then number 2 says, which of the following can be obtained by fractional distillation? Nitrogen from liquid air. Exactly. You can prepare nitrogen from air by fractional distillation. You know that I will explain number 1 calculation, but number 2 is self-explanatory because in distillation, especially fractional distillation, is based on differential boiling points of the mixture, and remember that they should be miscible. A is a mixture of gases, nitrogen, oxygen, carbon dioxide, noble gases are all contained in the air. But nitrogen have a quite different boiling point from oxygen, and these two are the major constituents of air. So it's easy for one to do the separation by fractional distillation. I think the boiling point of nitrogen should be minus 196, and that of oxygen should be minus 183 or 250 something if I can remember. So the answer is A, nitrogen from liquid air. Then the other one, okay, number 3 says duralumin consists of aluminium, copper and what? Duralumin is composed of 4. There are 4 elements there. Good afternoon, welcome Chidera Hillary. You are a bit late today. Thanks for joining us again. So duralumin consists of aluminium. It's an alloy of 4 elements, and they have helped you. Aluminium, copper. Please, there are, I call it ACMM, or you call it MMAC. The 2 manganese and magnesium is the answer. That is that is option D. So we have duralumin consists of aluminium, copper, manganese, and magnesium. So magnesium and manganese joined with aluminium and copper makes duralumin. It's an alloy used for making the body parts of aircraft because it's lighter in weight and I think it resists stress. Then an example of a polysaccharide is D. The starch is a good example of polysaccharide. Please, glucose is also dextrose sugar. Often you see where they wrote glucose D, and this glucose D, the D there means dextrose, which means we might have glucose L. This is all about optical isomerism. We have glucose D and glucose L. That's Lavio and dextro, alpha and beta glucose, depending on your own terminology. Then mannose is also a simple sugar. I think a 5-carbon simple sugar. Glucose 6-carbon simple sugar. Remember, 6-carbon simple sugars are called hexose sugar, but starch is a polymer and is a polysaccharide. Then 8 grams of methane. These have to do with calculation. 8 grams of methane occupies 11.2 at STP. What volume would 22 grams of CH3 CH2CH? This CH3 CH2CH, I don't think is a okay. Oh, CH3 CH2 CH3. There is 3 here. please, your work here is just to, I will do the calculation here, but a mere look at this, I think is predicting the answer to be, I'll teach you how. It's going to be B, because the moles are the same. It's going to be 11.2 actually. Okay, let's go to our solving board and show you some of those things I've said, starting from number 1. Okay, this is the page created for today's live stream. So I will try lifting the question. God help me to get the question 1. I don't know how this is arranged. Oh my God. Okay. So this is question number 1. It asks us how many unpaired, and I say that the answer is 3 unpaired. Now let me show you how and why. So I'm going to minimize this. So I hope you can still see the question as I solve. It says, you know, that we will concentrate in the last share, in the last orbital, which is 3p3. So, and remember that P, P, I can't get you well, you that just put a comment now. P orbital is divided into 3 degenerate orbitals. So we have extra 3 here. 1, 2, and 3. Then remember that according to Horn's rule of maximum multiplicity, that in a set of degenerate orbitals, the pairing cannot start until each of the orbitals have gotten at least 1 electron. Therefore, the only correct way to put these electrons are they should have 1, 1 each. And this shows that it is not paired. Therefore, we have 1, 2, 3 unpaired orbitals. So unpaired orbitals are orbitals that contain only 1 electron. Remember, each orbital have the ability to have 2 electrons on the maximum. So when it has contained 2, we say it is paired. Let's assume after the configuration it is like this. Then the answer becomes it has 2 unpaired electrons. But when after configuration, that is for 3p5 for example, you say that it have a okay, I see your answers. You tried much. Then mark yourself as I do the correction here. So in this case, if they ask you how many unpaired, the answer is 1. But to this question, the number of unpaired electrons is 3, as you have seen now. Then question number 2. This thing has refused to. Okay, that's it. Question number 2 says, which of the following can be obtained by fractional distillation? I've answered that: nitrogen from liquid air. So then we go to number 3. This 16. How is this thing arranged? It's like I'll go back to the original question. I'll have to divide the screen into 2. We say that 19 is C. Okay, when we get there, we'll see how it is. How can I see this? I thought this will be arranged. We have 6 and 7. Please, I'm going to go back to the video, or I'll have to divide the screen into 2 now. I will have to do that now, so that we'll be able yeah. So Please, this is what I'm going to do now so that we can handle it. So you can see question 3 say duralumin. I've answered what it is. Question 4 say an example of polysaccharide. I've explained that. Okay, question 5, which involves calculation. That question number 5, I'll be using this half for solving today. That number 5 says 8 grams of methane occupies 11.2. Remember, according to Avogadro, equal moles of gases have equal volume at the same temperature and pressure. And the question says under the same condition. Watch it well. It said under the same condition. So what we have to do first, convert 8 grams of methane to mole. And methane, molar mass of methane is 16. And mass over molar mass, that's 8 over 16, gives you 0.5. That is half. So 0.5 moles of methane have 11.2. So therefore, you now check the molar mass of this here. How many carbons are there? We have 1, 2, 3. There are 3 carbons, and 12 times 3 is actually 36. You are doing well. You are doing well there. I cherish your ability. Okay. 12 times 3 is 36. Then plus how many hydrogen? 8 hydrogen. So 36 plus is actually 44. 36 plus 8 is 44. And half of 44, I'm teaching you how to use normal reasoning without wasting time. Half of 44 is 22, which means it's 0.5. And 0.5 will have the same volume. Answer is automatically B. You don't waste your time solving this. It's in the same ratio. 8 over 16 is 0.5. 22 over 44 is 0.5. Therefore, equal moles of gases will have the same volume. So the answer is B, which is still 11.2. So let's go to the next question. Okay. Number 6 here says the best treatment for a student who accidentally poured corn tetroxosulfacic acid on his skin in the laboratory is to wash his skin with. Please don't be tempted. The best way, because as experienced I am in the lab, I've encountered, I think around 2011, one of my students added water into acid. He wanted to try what will happen, and lo and behold, it splashed into his eyes direct. But as God may have it, I was around. You know what I treated it with? I treated it with very dilute sodium carbonate, sodium bicarbonate. So very dilute sodium bicarbonate is very advisable, very, very dilute and cold water. Then I now flushed with excess cold water around. So please, the correct answer here is you have to wash, the student have to wash the skin with cool running water. That's the best. Though dilution of conc H2SO4 is actually exothermic, it will burn the skin more. But it is preferable to use this cool water than to use neutralization process. That's using sodium hydroxide. Please, sodium hydroxide, of course, will quench the burning effect, but will burn faster. It will cause more burning because neutralization is exothermic. It will release more heat, and we are not helping matter. So the best way is to wash with copious water, dilute sodium hydrogen triazocarbonate for solution. I'm speaking from experience. Don't you ever use sodium hydroxide solution, because that particular thing will be so harsh for the person. So please, the answer is A. That's question number 6. Then question number 7 says, which of the gas laws, okay, let's play it. From here, you see the question well. Which of the gas laws does this graph illustrate? Please, in exam, you don't even need to waste time. Don't go memorizing the shape and the curves and look up. Just when you look at this point, this is volume. I believe you can see it well. That's volume. And over here is temperature, which means you are not seeing pressure. And which law is pressure constant? Simple. And that law is Charles' law. So pressure is constant in Charles' law. This becomes automatically Charles' law. When you see the two parameters plotted against volume, temperature, Charles' law. But when you see volume and pressure without seeing temperature, that becomes Boyle's law. So let's move to the next question. Okay, question 8 says, what are the possible oxidation numbers of elements of an element if its atomic number is 17. This is very simple. This is chlorine, and chlorine exhibits oxidation number that starts from -1. In chlorides, chlorine is -1. Then in chlorates, chlorine is either 5 or 7. So we have chlorate 5, chlorate 7. So it starts from -1. According to this option, A is the correct answer. Then question number 9 says, what process would coal undergo to give coal gas, coal tar, ammoniacal liquor, and coke? Destructive distillation. It will undergo destructive distillation. Remember that destructive distillation, that particular compound or complex that have undergone this distillation is destroyed, is not recovered. And destructive distillation is a type of dry distillation. Dry distillation. It involves heating solid, then removing the volatile part of it. So that of coal, when you heat it, it is destroyed. You can't get it back. Unlike in petrol, distillation of petrol is not destructive, because if you mix back kerosene, unlike in petroleum, that's not petrol, please. When you mix kerosene, petrol, diesel, all those components back, it will form back crude oil. No new substance is formed. So destructive distillation is a kind of chemical change. Is a kind of a pure chemical reaction. Okay, we move on. Remember to ask your questions where necessary. Okay, number 10 and 11 says liquid black soap is made by boiling palm oil with liquid extract of ash. The function of the ash is to provide this is very simple. This is how local soaps are produced. Please remember that when woods or when plants grow in a soil, they absorb potassium from potassium nitrate. So they retain it. They are source of potassium. So potassium hydroxide are found in wood ash. So it is going to make it alkali. It's to provide the alkali needed. So it's a kind of saponification reaction whereby the base is provided by the ash. So the answer is C. So number 11 says when water drops are added to calcium carbide in a container and the gas produced is passed through a jet and lighted, the resultant flame is called oxyacetylene flame. Simple. Because when you add cold water to calcium dicarbide, it's seriously exothermic, but the gas that comes out is ethane, that's acetylene. So now passing it through a jet which contains oxygen gives you oxyacetylene flame. So 12 says which of the following substance is a mixture? Granulated sugar is a pure compound, seawater is a mixture, sodium chloride is a pure compound, iron filling is an element. So the correct answer is seawater. If the quantity of oxygen occupying 2.76 liter container at a pressure of 0.825 atm and 300 Kelvin is reduced by half, what is the pressure exerted by the remaining gas? Just use combined gas equation or general gas equation, which says P1V1 over P2V2 equal P1V1 over T1 is equal to P2V2 over T2. Here you are going to make P2 the subject of the formula. So let's go back here and solve with the help of our calculator. So please, if you are still there, please, it's nice to know that you're online and your questions are welcome, please. So coming to our solving board here, we use P1V1 equal to P2V2, then divide all by T1, divide all by T2. So make P2 the subject of the formula. We have that P2 is equal to P1V1 T2 divided by T1V2. So you substitute these values given. What's our first pressure? The first pressure given is 0.825. So 0.825 times what's the volume? 2.7. That's 2.7 dm cube. That's the same thing as liter. Then temperature that was mentioned is 300 Kelvin. Then divide by T1, that's okay, T2. What's happening here? What's our T2? Okay, liter reduced by 1/2. What is the pressure exerted? I can't see the second temperature here. Okay, let me reason out this. Okay. This is the pressure, the first temperature. No second temperature was mentioned. So if I assume that temperature is constant here, okay, I'm going to assume that temperature is constant. That's the only thing. And when temperature is constant, that makes it a bit easier. Then the same 300 is still the same. Divide by V2 is reduced by 1/2. That's half of 2.7 is okay, 1.3, 1.35, so 0.85 times 2.7, then divide by okay, we'll give you 1.65. That's option A. Option A is the correct answer there for that gas law. This number 13, 1.65. Since they didn't give us two temperatures, we assume that the temperature is constant. Okay. Sorry about the background noise. Okay, we have 14. 4 elements P, Q, R, and S have atomic numbers 4, 10, 12, and 14 respectively. Which of these elements is noble gas? Imagine that. They said atomic numbers. So is that of Q, of course, because that should be neon 28. Please, the answer is Q, which is B, because neon is 10. 12 is magnesium. 14 is silicon, of course. Then 4 is your beryllium. So the next question says, that's 15. The products of the thermal decomposition of ammonium trioxonitrate 5 are, when you heat ammonium trioxonitrate 5, what are the products gotten? Please, but before I answer this question, is actually, okay, the answer is laughing gas, and laughing gas is dinitrogen 1 oxide and actually water, nitrogen 1 oxide. So option A is very correct. But be careful here from experience, please. Heating ammonium trioxonitrate 5 is explosive. So in the production, you have to be very, very careful. Or less, you mix up ammonium chloride with sodium trioxonitrate 5 and heat together. This one will be safer than heating ammonium nitrate straight. So the answer is A, nitrogen 1 oxide and water. And nitrogen 1 oxide is called laughing gas. So to show the equation of the reaction, the equation of the reaction is NH4NO3, action of heat so action of heat on this will give you nothing but N2O plus H2O. So your job is to balance the equation. You just put there should be 2 here, and the 2 there makes the equation balanced. We have now the case is settled. Now we go to the next question. So 16 says how many valence electrons are contained in element this. You know, valence electron depends on the number of electrons present, and this is a neutral element, which is 15, which means 285. So the answer is actually it remains 3 now to reach 8. So you take it, A is the correct answer, please. The valence electrons contain this element. When you say valence electron, you can take it as outermost share electron, or the number of electrons required before the share becomes octet stable. So if you do this, which is phosphorus is number 15. Phosphorus is 285, which means it has 5 in the outermost shell, but there is no 5 in this option. That should not actually destabilize you. You just say how many does it require now before it becomes 8. That's 3. That if you say 3 plus 5, it gives you 8. So it can, remember, valence can be combining power of an element. So phosphorus have the combining power of 3. That makes the answer 8. Okay. The other one says, oh my God, it's covered. Let me check if I can find it from here. That's question. That should be probably question 17. Have patience. Let me look for it here. I can't get you. Say that the camera is what? Where are you, this question? Come on. Okay, I'll continue. I can't see I can barely see the thing well there. So question 18 says the volume occupied by 1.58 gram of a gas at STP is 500 cm3. What is the relative molecular mass of the gas? Simple. If 500 cm3 occupies 1.5, whatever 22.4, that is 2204 this thing. Check your phone. You see, only you. The camera is very, very clear. Please. The camera is clear. Just bring it closer or increase the quality you are using to watch this live stream. You see that the camera is clear. Okay, let's treat this question here, this calculation. So the question says if 500 cm cube, when you convert to dm cube, is automatically 500 divided by 1000, which will give you half. So we have 0.5 dm cube with 1.58. So whatever 22.4 dm cube weighs is the molar mass. So cross multiply what we have, or even if you don't want, it means 1.58 divided by 0.5 times 22.4 over 1, such that we have 1.58 over 0.5 times 22.4. So you can see where the answer is. So the answer there is actually, it shows that that should be chlorine gas. That is 71. Okay, then that's D. Then say which of the following gases will rekindle a brightly splint, rekindle a brightly splint, or rekindle a glowing splint. I don't know how they put this question, but there are only two gases that rekindles glowing splint. You can check this video on my channel, how to produce oxygen and test for oxygen, and also how to produce laughing gas and how to test and confirm for the presence of laughing gas. There are two gases that does this, laughing gas and oxygen. So it's actually entertaining when you watch this video. The answer here is N2O, which is option C. But there is, in those videos, I differentiated oxygen from laughing gas because both show similar property with in terms of glowing splint. If you insert this grammar means if anything is burning and you extinguish it, if you put it back in oxygen or nitrogen, it will relight. That's what it means by rekindling. So, but oxygen forms a reddish brown gas when you combine with NO, then is absorbed using heated copper. But nitrogen 1 oxide doesn't form any reddish brown gas in the presence of nitrogen 2 oxide. So there are other differences. Oxygen is odorless, colorless, but nitrogen 1 oxide have a slight pleasant smell. So watch that video here, rekindle your flame. That's production of oxygen gas. I tested it, not theoretical. Please, I encourage you to do science do science practically, because Her Majesty's World Science Channel is keen on doing the reality of science. Okay, we continue. Here it says the shape of ammonia molecule. If you have watched my stream 1, this question appeared there. So the shape of ammonia molecule, according to this option, you just take trigonal planar, but it should be actually trigonal pyramidal. I've explained the reasons in past streams. So the question number 21, but according to this, take trigonal. So ammonia molecule is trigonal. So, and that's the only option. Octahedra is for diamond, is octahedra, of course. Then square planar, I wouldn't remember which one is that. Then tetrahedra is methane and most of the alkanes, which are having carbon atoms with sp3 hybridization. Then coming to question 21, a few drops of concentrated hydrochloric acid are added to about 10 cm cube. Let me remove this play button. We are into question 21. A few drops of, so that it can be very clear. Few drops of conc HCl are added to about 10 cm cube of a solution of pH 3.4. The pH of the resulting mixture is it going to be less? Is it going to be more? Is it going to be unaltered? It said the same as that of pure water. Will you go back to neutral? Okay, it's obvious. Remember that 3.4 means acidic and you are introducing more hydrogen ion molecules. Remember that pH is the measure of a negative logarithm of hydrogen ion concentration to base 10. That's negative natural log of hydrogen ion concentration represents your pH, and pH means potential hydrogen. Please, if you add more acid molecule, you are increasing the concentration and thereby decreasing the pH. So the pH will be less than 3.4 because the more acidic a solution becomes, the lower the pH. So if you increase the pH of a solution, you are making it more alkaline than acidic. But when you lower the pH, you are making it more acidic than alkaline. Okay. Question 22 here says chromatography is used to separate components of mixtures which differ in their rates. In chromatography, there is what we call mobile phase and stationary phase. So, and this thing, the mobile phase is what is migrating across the stationary phase. And the molecules have different speeds. Because of their different molecular weights also, they migrate at different speeds. So it is actually used to separate based on migration ability or the speed at which they move. So molecules that move at the same speed on a particular medium, that is the stationary phase, cannot be separated by chromatography, and this is mostly applied in separation of colored substances. Okay. Then 23 says the liquescent substances are also efflorescent, anhydrous, hygroscopic, D insoluble. Okay. The liquescent substances, according to this option, of course, they're hygroscopic because they will first absorb moisture. I'll come to your question. When steam is passed over red hot coke, it's very simple now. If you are reacting steam over is a reaction that shows I'll come back. It's just a reaction that shows the reducing ability of carbon. It will reduce the steam to hydrogen gas automatically now and increase itself to carbon 2, and this mixture of gas is called water gas. So I've indirectly answered you, though I said I'll come back to you. So I've answered your question. When you pass coke, that's carbon, over steam, or you pass steam over coke, you are getting nothing but a water gas, which is a mixture of carbon dioxide and hydrogen gas. But when you pass hot air over when you pass hot air over red carbon, that's heated carbon, you are getting a producer gas. There should be mixture of nitrogen gas there and other things. So that's just the question, the answer to your question, please. So the liquescent substances are also hygroscopic, though this question is a bit ambiguous. But in this case, answer C, because they will first absorb moisture then before turning into liquid. Remember, efflorescent are solids that loses water when exposed to atmosphere. So they get drier by losing water. They are perfect wetting agents and not drying agents. Anhydrous means without water at all, without water of crystallization. Hygroscopic means substances that absorb moisture, that absorb water and become moist, not to form solution. They absorb with control. They are perfect drying agents. Insoluble, these are actually things that don't dissolve. So the deliquescent dissolve. If not, they won't absorb. There is no insoluble deliquescent I have not seen yet. Okay. 24 say helium is used in observation of balloons because it is, use helium or hydrogen, but the high flammability of hydrogen has made it not suitable for this observation. So helium is lighter than air and floats. If you watch my video here where I showed gases that are lighter than air, where I produce hydrogen gas and I suspended it, confine it in a balloon and send the balloon to air. So normally in weather studies, you can use a little thing and tie the balloon. When it goes up there, you can bring it back. You can use it to determine the nature of what is there up there. So helium will also float, but as it floats, it expands more and more. But helium is preferable to hydrogen because it's non-combustible, unlike hydrogen that will combust. In any slightest mistake of coming in contact with an open flame, it burns. But this is unusual. This is not the case with helium. So the answer is because helium is light and non-combustible. That's question B. It's not heavy. Then the other question says 32 grams of anhydrous copper 1 tetraoxosulfate is dissolved in 1 dm cube of water generated 13.0 kilojoules of heat. The heat solution, there is nothing like heat solution, the heat of solution. Please, heat of solution is actually the heat released when 1 mole of a substance dissolves in 1 liter of a given solvent. So, and they told us that this was dissolved in 1 dmq, which is 1 liter. Your work is to convert 32 grams. Your work is just to convert these 32 grams of anhydrous copper 2 tellurose of a 6 to mole. And for you preparing for this exam, you should know that the molar mass of CuSO4 is automatically CuSO4. The molar mass is 160. Know it today. So if the molar mass is 160, then mole is equal to mass over molar mass. Then the mass given is 32 over 160. So 32 over 160 will give you 0.2. We are working with 0.2 moles. So it means that 0.2 moles we are able to release this energy, 13 kilojoules. What will 1 mole release? So in that aspect, let's clean our board. So if 0.2, we are able to liberate this energy, 13 kilojoules, what will 1 mole liberate? That's 1 mole of that particular copper 2 tellurose of a 6. It will now be 13 over 0.2 times 1. So 13 over 0.2 times 1 will give you, you know that you can go back and just put points there. Although the other question that I could have used to teach you cheats on calculation didn't appear well. Okay, 65. So 65 is the correct answer, 65 kilojoule. I defined heat of solution as the heat change when 1 mole of a given solute dissolves in 1 liter of a given solvent. Okay, then we move on. Okay, 26 is still a gaseous metallic. Okay, it's not showing well. Maybe I'll try searching it here. But let me welcome your questions. As we do this, we might also take a little break.
Please subscribe, and yeah, we'll have a good time.
Extrinsic muscles of the eyeball. Different actions of the latissimus dorsi.
Remember to subscribe to Some Majesty is the World Finest channel on YouTube, and there you'll find a lot of amazing videos, and yeah, they are very educative. And subscription is free. Just go online and hit on the button. Thank you.
So this is a nice school, Fountain Comprehensive College, Enugu. I work with them. It's a nice school, so you can enroll your word there. You see how to get them. They are good people. I've collaborated with them. Then also make your business known with Her Majesty Easy World. So I will always be here to serve you as far as sciences are concerned. Okay, nice to see that you are still there. Please check other live streams and remember that your success is my topmost priority. I'm wishing you the best of luck. Please, I'm doing this just for you, and instead of making it private live stream, I made it public to make sure that you get the proper information you need to score above 90 in chemistry, and I know that this is a wonderful score if you can be able to make it. So please, and check other videos here at Her Majesty's World Science channel. As a Nigerian, you know, we always keen on the exams. Please, sciences are meant to be practicalized and applied. Science that have no application is useless. You are not studying science to just get certificates only. So check out most of my DIYs, how you can produce most things, your body cream, and most of them to be financial free. I teach science, I apply science. I teach chemistry, I apply chemistry. So chemistry is very nice. Check for also videos on actually human anatomy. There are many videos on human anatomy, as you can see here. See, you can check them here very well. They are clear, show you the scores and everything, and even in chemistry. So this channel is very nice for chemistry and biology related courses. The easy world of science loves you so much. So nice seeing you. Then this is DIY, where you can learn how to make your own body cream, even make your hair cream. There are many of them. Make sure you check them out here at Her Majesty's World Science channel. Please don't forget to also share my videos. Now we go back to the questions. Okay, this wasn't clear at all. Okay, but I think I can see it. I can see it beneath this. They say a gaseous metallic chloride MCl consists of 20.22% of M by mass. The formula of the chlorine, the formula of the chloride is, please, this is, since they have said M is 27, in exam, don't go solving. It's aluminium that is 27. Automatically it should be, okay, we have two possible correct options here. Since they say gaseous, in gaseous state, I think aluminium chloride is a dimer in gaseous state. So you should take that of D. In gaseous state is a dimer that is have a covalent property when in gas. Because C and D are all correct, but D is just a dimer of C. That is, D is equal to C times 2. So you should take that M2Cl6, because in gaseous state, I think magnesium chloride is a dimer. Okay? Then 27, what quantity of electricity will liberate 0.25 moles of oxygen molecule during the electrolysis of dilute sodium chloride solution? Please just know that 4 electrons are required to discharge 1 mole of 1 mole of oxygen. This one requires us going back to our solving board. They asked us the quantity of electricity that will discharge, if I'm right. So, okay, 0.25 moles of oxygen during the electrolysis. Okay, 0.25 moles. Okay, we look at it here. The calculation is simple. If you come to half cell equation, so half cell equation during electrolysis of dilute sodium chloride, actually at the anode, oxygen is liberated, but it's liberated in the form of hydroxyl ion. So hydroxyl ion will invariably gain 1 electron. So this is supposed to be 4 in number. If you write this into 4 times, that's only when you can get oxygen. So we have 4 hydroxyl ion, we form 2 molecules of water and 4 electrons. It means now, please, plus oxygen actually, O2, that balances the equation, then plus 4 electrons. It means that 4 Faradays are required to discharge only 1 mole of oxygen. So how many Faradays will be required to discharge 0.125? You call here X. So your job now is to cross multiply, where X is now equal to 4 times 0.125. Is that correct? Yes, of course. That should be X. So when you do this, it should be 4 times 0.125 is 0.5. So 0.5 F, which is 96,500 divided by 2. That will give you, this is the column, 4.825 0 columns of electricity. So let's go back to the question. So that's it. Option B is the correct answer. 48,250 columns of electricity is what is required. So number 20 is which of the following types of bonding does not involve the formation of new substances? Metallic bonding doesn't form any new substance because it's actually an attraction created by valency electron revolving around the nucleus. Being at the valency electron being attracted by the nucleus. So it is not. It doesn't form any new substance. Covalent forms, coordinate forms, electrovalent forms. So A is just the force of attraction between the metals. Okay, an organic compound that does not undergo reaction with hydrogen. Wait. An organic compound that does not undergo reaction with both hydrogen cyanide and hydroxyamine can be alkene, alkane, alkanone, alkanoic acid. So we are talking about undergoing the reaction here is, this should be probably an inert substance. They should react with amine. Hydroxyamine will react with alkanoic acid. Hydrogen cyanide will react with alkenes, of course. Probably it's supposed to be this from B or C should be the correct option here. So 30 says the substance often used for vulcanization of rubber is at least this is a bonus question. This should be solved for, please. So that brings our live stream to an end today. You ask your questions where necessary. I am here now. I know that this live stream is actually programmed to last for 45 minutes. Now we are getting to 1 hour. This is 58 minutes of the stream. So I am now here for you to bring your questions. I'm looking at your live chat now. Bring your questions to make sure that tomorrow will be good for you. Her Majesty's World Science Channel loves you. It is good to know that you're there. I'm now waiting for your questions. If I don't see them, we end the live stream.
There's something we call dangerous blood glucose. You know?
Thank you. I love you too.
Science and technology goes to work. Of course, yes. Proves two methods. Okay. Yeah, we have the time method and we have the tube method. Okay. Now, the tube method has advantage over the time method. Okay. Because you have to transfuse and now you have the transmission, which is yes.
So you can get your health tips here, your medical videos here on this channel. This is a young guy I trained now. He is a lab scientist. We did most things here in this lab. Check the videos on hematology. He taught us many things and we equally experimented. So after this, your JAMB, remember that Her Majesty's World Science Channel is still there for you for human anatomy, biochemistry, your health tips, in terms of pharmacy, even most of the health conditions that need to be treated. You can even see your doctors here. So please share these videos and don't move away far at all from Her Majesty's World. Stay tuned always. I haven't seen your questions, please, as I wait for them.
true. You don't even know how very special you came true. You don't even know how very special you are. Make it move, make it groove. Make it move, make it groove. Make it move, make it groove. Make it groove. Make it move, make it groove. Make it move, make it groove.
Okay, bring your questions. Bring your questions.
Just flow.
So today we learn how to make diisociated compounds of benzene. A diisociated compound of benzene because one remains better. So this is M-dichlorobenzene, while this is now P-dichlorobenzene because 1,4 represents. Let's see the next example. Okay, benzene. Then dibenzene is commonly called xylenes, but the CH3 CH3 are in one solution. This is called goxylene. This one can now be called benzylene, and this is called B. This is the vertebral column. So we will take a look at the bones that makes up the skull, the tree canal here. So that's where your ear should be. Let's place the ear there. Okay. That's where the ear is supposed to be. It is the temporal line. First, let's clean the board.
Hi guys.
My name is Shemika Arizi. I am a second year medical student.
My name is Sushma Tripathi and I'm a first year medical student.
We're here today to ask you to please subscribe to Sir Majesty Easy World.
It has home experiments and it makes science fun. So subscribe.
Please.
Make it move, make it groove.
You are still live with Her Majesty Easy World Science Channel. Please get your questions there in the live chat. So nice to know that you came around today. Remember, before we end this, let's play the questions for today. Today's questions are: Okay, thank you for coming around. I really care about you. Best of luck in your tomorrow's and the rest examination.
I love you. Thank you for watching.
And Omega.
I love you. Thank you for watching.
Alpha and Omega.
I love you. Thank you for watching.
Alpha and Omega.